Okay, so we're picking up on slide 43 on the screen, which you could not see, which now you'll be able to. So we started talking about functions, and I mentioned how functions, depending on the language, it might be called methods in some language, functions in others. They can have return values. They don't necessarily have to have return values. And in Python, really, it's the same thing, function with or without. But functions without return values is where we left off. Okay. We've already talked a bunch about these. We've shown you a lot of examples of this even. In their example here, they got a function called box string, which does something. It doesn't necessarily return a value to the calling area or calling method or wherever it was called from, but it does something. In this case, it just prints out a box with the word hello in it. Okay. A lot of functions just do something. Okay. So if I made a function to make a peanut butter and jelly sandwich, would that function return something or not? What would you think?
Return the sandwich.
It would probably return a sandwich, because the ultimate goal of the make a peanut butter and jelly sandwich is to end up with a peanut butter and jelly sandwich.
Okay.
Unless you want to print it. Right. I mean, we could literally have a function that makes it and needs it. That's gone. But then you would be returning something else a few hours later. But the point is, some return stuff, some don't. I would say I probably use more functions without return values than with return values. Okay. So one that I wrote recently with a return value was, I have a huge word list that I use in forensics. I don't know, 30, 40, 50,000 words in it. I wanted to randomly pick a word. So I wrote a function to open the file up, go through the entire thing, randomly pick a word, return the word, and close the file. So that would be an example of a function that returns something. So, that's, a pretty handy one. But, so we have them both ways. All right, using return without a value. So here, this example basically says, if n in this case is equal to 0, just return. In other words, get out of the function. Very similar to a break statement. Get out of it. Okay. It's not going to return a value, which is going to return from the function to whatever called it. Okay. So you can write them either way.
So what's the difference if you use a break statement or a return?
Really no difference. Really no difference.
There's a difference when you start getting into object orientation.
Yeah, object oriented is a totally different thing. And Python does support object oriented. And I was actually reviewing a book we might be using for another class that does have object oriented in Python. This one really doesn't get into that. But I'll tell you, if you get into the habit of using a return value, even if it's nothing, that'll be good for you. I mean, it's a good habit to get into because, like we said last time, languages like C always require a return value. So if you get into the habit of always returning something, whether it's nothing, a value, an object, or whatever, it's always a good idea. So it's just one of those things. It's really whatever you want to do. But just know that today, September 2018, Python's popular. But I mean, it was years ago when COBOL was popular. How many of you know COBOL? William, you've seen COBOL at least, probably?
I've seen it.
Yeah. I've taken a class in COBOL. Have I done anything commercially? No. You know it's still being used today? They even have object-oriented based COBOL. It's crazy, the stuff out there. The point is, if you get in the habit of using a return statement, either to actually return something or return nothing, it's not going to hurt you. Okay, it's really up to you. Okay, reusable functions. Okay, it says find repetitive code. Here they're trying to find stuff that's, we talked about this, I think, last chapter and even the chapter before. Whenever you're writing stuff, you're probably like me. I write code, and then I'm like, I probably could have written that easier. And that program I wrote for John the Ripper was funny because Ethan looked at it when I was like on version 5, which is still my current version. He's like, oh, I could make this so much better, which I probably could. I probably could as well. So I gave it to him, and that was last fall. He hasn't touched it. So the point is, code can always be made better. But a lot of times you don't get to it. Now, if it's your job, I could see actually getting around to it. Like when I actually wrote code for the military. That was my job all day in and day out was to write code. Yeah, at that point, you can really look for reasonable code, and but the majority of the times you really don't do it.
What was your most complex thing you had to do for them?
I worked in what's called ARMITS, Aircraft Radar Maintenance Training Set. That was what an E3, the AWACS with a little dome on top? Well, there's computer systems in there. Well, to fly that plane and run the radar, because the radar had to be flying to be in transmit mode. It puts out too much power to be on the ground. It would literally cook you. So they had to be flying the plane to actually be using the radar in full capacity. That's very expensive. So what they did is they made basically a simulator on the ground to simulate running it. And they actually hired a contractor to write it. The contractor was writing the code, and they were like $20 million over budget. And then they put in another budget increase, and it's be another $20 million. The military said, no, cancel the entire contract. The contract's over. So they canceled it. Contractor threw everything away. The military paid him $1 million to buy the trash, and then hired military people to fix it. That's what my job was. So we really wrote a system. It was using Pascal 286, which is kind of like Python because you had to declare it before you could use it. But it was running on what's called an IRMX operating system, which is a real-time operating system. And we wrote this thing that ran on kind of like a small mainframe kind of mini computer, but it controlled a video touchscreen system run by Laserdisc. Now we're talking back in the mid-90s. And this thing was really high tech for back then. It was all touchscreen. That was tough. That's the one where we had a module that literally said, you have no idea what this module does. Don't mess with it. Don't remove it. It must be here. If you went to compile without that module, I don't care what you compiled, it would crash every time. Never, ever, while I was there, could figure out what it did. And then, I actually left that area. I moved over to the networking area, but we had this captain who had multiple DUIs. If you know anything about the military, what happens when you get a DUI normally? You're pretty much gone. Captain wasn't gone. Because this captain was an amazing programmer. Because he literally came over to that area. Again, we had these special operating system, special language, special computer system, laserdisc, all this stuff. Big bucks. He comes in and looks at it, just looks at it. Comes back about 3 months later with a floppy disk. Here's your driver, it'll now run an IBM PC. And I'll be damned. It literally took the code, ran perfectly on an IBM PC, plugged straight into a touchscreen monitor. He got rid of the laserdisc, he got rid of the mainframe, he got rid of everything with a driver he wrote. Wow. Holy crap. So that's probably why he was not kicked out.
That or they wanted him on their side. It
might be. I don't know, but he was amazing. But no, so literally right after I left there, they got rid of the really weird stuff and went over to a Windows-based system. It was, yeah. In the real world, though, if you write programming for a living, and I wrote an accounting system for a company that sold marine stuff. And I wrote it. It was pretty complex. But then all of a sudden he came to me, wanted this many changes made to it. No, I'm not going there. And I told him that we switched to another software. But it's a lot of work doing it. But you got to enjoy it. I mean, if you like sitting in a computer all day long, I mean, I do. I love it. But I just got too much stuff to do. So. Reusable functions, like they're talking about here, are very important. You want to save redundant code. If you're doing something more than once, you're messing up. Roy down the hall is a prime example. Now, if you tell Roy to do something, he'll write a script to do it. Just because you might have to do it twice. Okay. I don't know. Did I ever tell you about the VPN I set up? I don't know if I ever told you that, but I set up a VPN between the Oklahoma Tower downtown. Actually on Northwest Expressway. The Oklahoma Tower from the VIP insurance company, there was an insurance clearinghouse. So all the insurance companies connect to them to get insurance data. So I set up a VPN between there and Edmond. They wanted to know how much I was going to charge. I told them $600. So I set it up. It took me maybe a week, I don't know, a few days. I got it all set up for $600. And they were like, wow, it works perfectly. Why'd you charge us so much? I'm like, because what my cost is. That's what I charged you. And then they wanted one set up from there to Dallas. And they're
That's
like,
a lot more.
Yeah,
and they're like, well, I mean, remember, VPN doesn't matter the distance. It's just configuring the endpoints.
Mhm.
So I don't care if you're connecting to China. It's really just configuring the endpoints. So this is how much to configure the second one. I said, it's $600. I mean, so this. And they're like, but that one didn't take you all that long. I'm like, sorry, that's my cost. They said, we'll do it ourselves. Go for it. So they worked on it for a couple weeks. Could not get it to work. Well, when I wrote the first one, I actually wrote a script to do it. Okay? So when they said, fine, do the second one, how much to charge? I said, $600. So I literally brought up my script, search and replace for Edmond to Dallas, hit submit, was done in like an hour.
Wow.
And they're like, how much? I said, $600. And they're like, crap. I'm like, it's way like this. So the point is, if you write something, and like Roy, he writes scripts for everything. If you need to do it again, it's all done. Saves you a lot of hassle. If you write functions correctly the first time, which is very hard to do, by the way, because you don't really know. So that John the Ripper one, I'm on version 5. Because it's like, ooh, we can make it do this instead or this instead. I mean, I cut the processing time down from way over 20 hours to about 2 hours. That was last year at Thanksgiving break I did that. So I would literally run it for an entire day over break. Drove my wife crazy because during the entire, I was sitting there on my laptop the whole time. Cut it down to about 2 hours. And, just by reusing code and making the code more efficient and, stuff like that. But so think about that when you're writing software. Again, in this class, you're probably not going to have much of an opportunity for that. But if you're doing something more than once, try to figure out a way to just do it one time. Because if you're doing it twice, you might need to do it 3 times. Then you might need to do it 4 times. And at what point do you stop writing the code every time? All right, so in here, they're really doing the same thing. They're really just changing some values, okay? So instead, you can write a parameterized function, a function that takes something. Like on mine, I had to return a prime number. I wrote one for cryptography. I had in cryptography, I have them do all these homework assignments. And a lot of them, like RSA, some of you might know what RSA is, reverse Shamir Alderman, okay? RSA normally works with a 200-digit number. You all agree a 200-digit number is a very large number?
Yeah, this is it.
Well, just for the sake of my classes, I use small numbers, single-digit numbers. Same concept, but a much easier number to work with.
Oh, RSA. I was thinking of RSA token.
Oh, well, it kind of, RSA is still encryption.
Well, yeah,
Public
same.
cryptography system. So I do it with small numbers. I had a student like 2 or 3 semesters ago. I'm sorry, I can't complete this assignment. It said specifically requires prime numbers. I'm like, are you kidding me? I told you I'm just giving you numbers to learn the concepts. I realize they're not the correct numbers. So what I did is I wrote a Python script to go out and randomly pick prime numbers now. I give it a range like they're talking about here. I give it the low range and the high range, and it picks a prime number between this range. So they're still not 200 digits long. They're only they're between 2 and 3 digits long. But at least now they're all prime. At least that student can't complain that, oh, I can't do your homework because it's not a prime number. So, but writing that function saved my life because now I literally can call that function whenever I want, and it just returns a prime number between whatever range I want. Which is very nice. I don't know about you. How many of you memorize all the prime numbers?
I know up to like 50.
1, 3, 5, 7, 9, 11, 13, 17.
19.
Oh, I meant 19. 17, 19. But the point is we don't know a lot. So I wrote a function to do it. Okay. So writing something like that is very beneficial to you, especially when you're software programming. Yeah, if it's tough, write something to do it for you. Okay. There's the read. We're not going to walk over that one. Okay, now let's talk about if and if else. We know what an if statement is because you guys did that on your fourth program or third program. One of the programs you did that. You did a bunch of ifs. Well, there's also if else. I don't even show much about it, but here you can do if else, or if elif, in other words, if else. So you can have multiple steps in there. So a bunch of different ways to do it. They don't really talk much about it. Now, here they're talking about stepwise. It's to solve difficult tasks, break it down into smaller tasks. Okay, I copy a lot of recipes off the internet. Does anyone do that? You ever find recipes on the internet? We all do.
Yeah.
And I have a program called AnyList, which a relative turned me on to, which is an electronic shopping list manager or whatever, but it also supports recipes. Well, I'll a lot of times import the recipes off the internet, and when it does it, it'll give me like all the steps in one step. You know what I mean? So instead of, 10 or 11 steps, it puts them all in as one. Then I have to go and break them out. Why do recipes break things out in steps? And first of all, it's easier to keep track of what you're doing.
And the time involved.
The time involved. This step, maybe you can do concurrently with this one, or maybe I do this one first. When it was all in one step, it was just so much more confusing. So what they're talking about here is if you've got a big task, break it into smaller tasks. Okay. Did you ever go shopping with a relative or a friend or a family member and, hey, you go get this, I'll go get this, and then we'll meet up? It's the same thing you're doing here. My wife will go get this, I'll go get this, and then we meet up, and then rather than going to both places, you just have to get one. Okay? It says then keep breaking down the steps into simpler and simpler tasks. Getting coffee, first of all, I don't drink coffee, so I don't know about that. Does anyone here go to Starbucks every day?
No. That's why
So many people do that. It's so crazy.
There's a Starbucks at my work that I go to. I only get like their cookies. Their cookies are
I
good.
think I've been to Starbucks one time with my wife and she bought a muffin. I can't.
Their muffins are good too.
All right. So get coffee. It says, can you ask someone? Yes or no? Ask for coffee, make coffee. The point is, break it down into steps. In this example, you got to decide, are you going to make your coffee or are you going to brew your coffee? Which one's easier? Now, with Keurigs, it's kind of the same thing, isn't it? Does anyone have that maker at home which grinds their
like
beans and all that crap? You do? You got to actually use that all the time? Wow. See, a lot of people do. I don't know it. I've never even tried coffee, so I don't know.
Never had coffee? No,
I
I
hate it.
I ate coffee ice cream once. No, it wasn't good. See, my dad would literally drink coffee until beer time came around. I don't think he's ever done anything but coffee or beer. So I just really don't do either. It's easier that way. So,
Yes.
yeah, pretty much, a lot of times you hear you're exactly like your parents. Oh, no. Exactly the opposite. So if you see the way I am, my parents were the exact opposite. But no, so you can break down any task. They talk about instant coffee, you can use the macro, you can use the kettle. I just don't like this example. Again, I wouldn't know grind. I can't stand going through that aisle in the store. Oh, the one that stinks really bad with all the coffee beans. Oh, I can't.
If he doesn't
stand
like, if he's never had it, he
No,
doesn't like
yeah.
the taste of
Oh,
coffee.
yeah, my wife-
He's not like
it. I'm so amazed.
I
No.
like the smell.
No.
I don't like the taste.
I don't like coffee roll.
Did you eat coffee ice cream? It's so nasty.
I like
No,
Ah,
I
I've
don't
never
like
had that
coffee.
exist.
I had coffee cake yesterday.
No.
coffee cake.
Y'all are wrong. Y'all just need to give up. You're wrong.
That was also from Starbucks.
So I'm not going to walk through the rest of their example here. Okay. So they're just talking about breaking things down, which you can read through this if you like. Naming subtests. That's kind of important because naming a function helps to know what the heck it does. The function's called tests. Like I am a prime example of what not to do. When I'm first writing something, I'll call it test. And I always try to go back and rename it, but a lot of times I don't. So naming something is very handy.
Test 1, test 2, test 3.
Writing pseudocode helps. William, we just watched out. His pseudocode for his last program was amazing. It was very detailed, exactly what it's going to do. Then you can very easily convert it to whatever language you want to do it on. Okay?
I guess that's why he started doing. I really need to start rewriting my code.
Yeah, and he mentioned it last class period that in the real world, if you don't write comments, your code is considered worthless. It is. because you can't understand it. I mean, can you imagine building your house without a blueprint? No, I mean, I couldn't do it. I mean, that would be crazy. I made the blueprints for my room addition going on right now. That's just because I'm kind of anal. I kind of like doing that stuff. And I tell you, when I went to get the building permit, oh my God, I never wished that on anybody, by the way. The guy was thrilled. He was like, wow, this is like an amazing plan. I'm like, yeah, I went to floorplan.com. I mean, designed what I wanted. The only thing I didn't have was the plot plan, but you know, I finished that while I was there. But planning things out made things so much easier. When they were building my house, I have a very large span of a living room, and the building inspector came out and failed it because the span was too great and the beams weren't enough to handle it. I guess it held it, but I guess over time it might not be able to. So they had to go in and put double beams in all of my rafters. Yeah. So I'm glad they did check that, but why wasn't that included on the initial blueprints? I don't know. So it makes you wonder. So when they designed my house, they probably could have put that in there. But so planning it, kind of an important thing. Keeping track of what each method is going to do, also important. Okay. And they have convert something to Python. It's not hard to convert it back and forth. So we're not going to walk through that one either. Yeah. Okay. And you can walk through some of these examples. They got more tips for you about walking through them, about making sheets. You can look through that if you want. Variable scope is important. We need to talk about this. Okay. The scope of the variable is where is it available. For instance, you know, in here, I can call William. And yes, there's two Williams in the room, and potentially either William could answer. But can you imagine, like if we were an OU and had 400 students, and if I called William, how many Williams would answer?
Yeah.
Yeah, it could be, you know, 50 of them. Point is, the scope is where is that variable valid? Where can it be used? Okay. So there's something called local, and you also have global. Local means, like local would mean it only works inside this class. A lot of times you hear that, you know, this doesn't leave this room. That would be a local statement. It only pertains to this room. It doesn't pertain to Arlene's class across the street. When creating variables the same way. Use as many local as possible. You don't want to use global. That's what they mentioned down there. An example of global. Way back in the mid-90s, I was hired by a banking company to convert a Visual Basic program to work on the web. The idea was have the ability to log into a website, log into your bank, see your bank statement, see pictures of your check. We have that today, don't we? I wrote that way back in the 90s. Somebody wrote a Visual Basic program to do it for internal to the bank, and I converted it to the web. The problem was the entire program worked with global variables. So in other words, I couldn't track where anything was going, what it was doing, so I had to rewrite the entire thing. I got the prototype working. It absolutely worked flawlessly. Then the best, it was so funny. I got so pissed. Get it all done. We present it to the bank. Yeah, that's really cool, but we really can't see the need for that. We cannot see why anybody would ever want to check their bank statement or view a check online. Seriously? So they didn't buy it. I mean, don't we all do that now? When's the last time you went to deposit a check at the bank?
Oops,
The only time I do that is if I get a check over $2,500.
I
You go to the
do it
ATM and deposit it.
No, you take a picture of it. You do realize you take pictures of your checks and deposit them that way?
I don't think FMB does that.
Yes, they do.
Do
They had one of the very first ones available.
Yeah, most of the time you do that, it takes like 2 extra days to get it processed.
Oh, no, mine's available immediately. But it also depends on your balance and your credit rating with them. I deposited an $11,000 check the other day. And it was funny. I asked the guy, so when will this be available? And he looks at my account. Oh, no, it's available for you immediately. I'm like, okay. He said, now if it does bounce, we're going to take it back from you. So if you have the money in there, they don't, yeah, there's no hold on. FMB's had it forever. They've had Apple Pay forever. They've had everything. You're just behind the times.
I guess so.
But the scope of variables are very important. So how do we choose? What I tell people is, in every single class you're going to take, you're never going to need a global variable. Never. There's no need for it. I think in my day, I might have used one and that was in my compiler program at University of Tulsa. Because it's very, very few and far between. Did you find it's on there, isn't it? Amazing. Imagine that. I do it all the time. It's literally, they'll normally do pending the same day, and it's available the very next day. All right. Here's some examples of scope. All right. So we have a variable called sum, another one called I, one called square. Okay? Sum is available for the entire main method in this example. I is available just inside the for loop. Okay? See that? Square is available from the for to the print statement, and that's it. Okay? So that won't be available outside. Okay? Kind of a weird example. Here's another example. Side length is available inside of main, but that's it. You cannot use it inside of cube volume. They're trying to here is going to be like, it'll be undefined, whatever unknown variable or something like that it will come up with. Okay. All right, reusing names. You can use the same names over and over and over. A lot of times in class, I will use the same name, but you don't have to. And I actually most of the time don't because I don't like reusing the same names, but you can. In this example, they have result used two different areas. So the result inside of square is only valid in square, and the result inside of main is only valid in main. And even when they print result, again, result, that's printing the result from main. Okay. Global variables. Okay. It says variables that are defined outside of functions are considered global. So if you define it beforehand, it's considered global as long as you use the global declaration. You probably never need to do this, but I'm going to show it to you. Okay. In this example here, you'll see balance is defined before withdrawal. Okay. Well, inside of withdrawal, you also see they say global balance. What they're referring to is they're not referring to another variable inside of withdrawal. They're referring to the global variable balance. Okay. I don't like doing that. Normally what I would do was I would withdraw, I would return the withdrawal amount and update balance. But in this example, kind of a cheesy one, balance is defined before withdrawal, and inside of withdrawal, they're using the one that's defined beforehand just because they're stating global. They're saying global balance, which means don't create a new variable, use the global one.
Yeah.
Yet I don't think you will ever need this. I don't recommend doing this. I don't even do this because there's just not a real big need for it. There's other better ways to do it. Global variables is just, it's just not a good programming practice. All right, and just like they say, there are a few cases where global variables are required, but they're quite rare. Literally, I think I used one in years and years and years of programming. Okay. It says programming of global variables are difficult to maintain and extend because you can't tell what they're doing because the variable just exists everywhere and it's just not good. Instead of using global variables, use functional parameters where you're passing values in and getting return values rather than having this big all-encompassing variable that can be updated from anywhere. It's just not a good idea. Okay. Graphics, I don't think we're not going to walk through this graphic one. I think that's all we're going to do in this chapter. I'm going to mention recursive, but we're not going to do it. Recursive is a function that calls itself. If we do it, Summer will drop the class. And so will Caitlin. And we'll both have a nervous breakdown and quit. Maybe I'll save that for like the test. Give you a project.
How about no?
Gets up, walks out of heads.
Yeah, recursion is tough. It's very hard to write correctly. Once you get it right correctly, it's like, wow, this is so awesome. The big deal with recursion is you must make it terminate. If you don't make it so it terminates, I mean, it goes on forever. Okay. Here's an example. There's a method called print triangles that receives the length of the side. And if the side is less than 1, return, in other words, quit. If it's not less than 1, call print triangle. passing it to side minus 1. So it's going to continually to call itself and print the side until the side is less than 1 and then return. It's just a little confusing to do, and I'm not going to require you to do that at this point at least. If we do it later, we'll cover it more at that point. Okay? Sound good? They're talking about it a little more. I'm not going to walk through it. That's the end of this chapter. Now I'm going to close this out, and then we're going to see if anyone wants to talk about your next program, which I'm not going to record because people should already be working